Let me show how to calculate project using pipeIQ software. Let me start pipeIQ. Okay, create a new project. Let me name it calculation. Okay. Warning that we must comply local standards. I have a metric standard. I will use Faast LT. There are also other devices, but I have Faast LT. Okay. For example, I have two channel sensor detector. Pressure is okay for me. Daylight saving, I will not use it. External input resist fast, okay, let it be. Channels enabled. Fire alarms. Okay, so fine. Now we go to design and start designing and two channels. So we will have two tubes. For that, I will use wizard. For example, first tube I will use class A. The maximum coverage is only 25 square meters. My pipe I will use ABS pipes. Pipe diameter is 25 and sample hole size let it be 3. I will change it after. Okay, room length. For example, it will be 3. Okay, let it be default inside the room. The detector is located inside the room, and left to right, one inlet is in use. Okay. Pipe location is below ceiling, and the distance of the tube below ceiling is 10 centimeters. I will not use capillary tubing. Okay, this is the general information for my room. So I have length of the room 3 meters, width and height 4.3. Okay, then it proposed me such device. Let me see. Okay. So what's important that in isometric view I have no tools enabled in toolbar. Okay, let I rotate detector this way. Okay, and for example, I don't like this tube. I will delete it. And I will create my own tubing, vertical tube. Okay. Too long. Let me specify tube. Let it be 1 meter length. Distance to first hole 0.5. Distance between holes, and you see I have no holes at all. I will push OK. Now I must select tube. Tube is selected with the detector. I hold Ctrl while selecting and press the connect pipes. Okay, let me see. The pipe is connected to channel 1. As you see, I am drawing channel 1 at the moment. Okay, let me continue. For example, I have the horizontal pipe, and let it be the length of, for example, 8.5 meters. Distance to first hole I will put to 2.5, and distance between holes I will put, okay, let it be 5 meters. Okay, now I must select two pipes. For that I select the first pipe, and then I select the second pipe. and I press connect. Okay. I also can rotate this by using the flip toolbar button. I don't need that now. Okay, I choose again two tubes. I connect them again, and now let I see the properties on the pipe. For that, I select the pipe and press right mouse button and select edit properties. Now you see I have no holes in here. I will press update the holes and add the end cap with the sensing hole. Actually, we'll add end cap but with no hole. So, okay, I'm done. I have two holes. You see, and now I can calculate, is it okay? The flow is 14, is too low. For that I must update the hole diameters. I actually can auto balance it and it will tell which is the best way. But let me choose manually 6.5. And you see the distances, absolute distance to the first hole, and you see the flow now is not the red. It means that it's okay, and the flow control can be changed with the fan speed. I will choose 10 and, for example, okay, yes, apply the configuration. But that's not all. For example, I want to have the hole here as well. I can choose it here, and I can choose I have the length of the pipe and the distance to the first hole. I can update it. And you see I have the hole diameter. However, when I add it, then my calculations of this pipe are not correct already. And what else I can tell you? I can insert hole and put distances as I wish. For example, okay, here, for example, 0.1 and this one should be 0.3. And you see all these settings are updated. Let me see. Okay, when I press OK, then the maximum holes count already for A class are not working. For that, I must delete one of the holes. Let me delete this hole. For example, I don't need this hole. Okay, but now see the calculations. The calculations are updated. So I must again set correct parameters to comply with these calculations. The sensitivity is too high. Okay, let I choose the bigger diameter, and you see the flow is too big. Okay, then I choose the fan speed 1, and then the flow is okay. So this is the way how we can configure it. But for example, I will use smaller holes. But you see, when I change the hole diameters, then the transfer time and sensitivity is changed automatically. See, now I have transfer time 0.1 seconds. Now I put diameter hole 5 and the sensitivity is red. It means that it's not too sensitive for class A, and the transfer time is too big. Okay, let me choose it back to 6. Imagine that we completed our setup. Yes, it's all okay for us. Now we can see the reports, pipe layout. Okay, report pipe layout for channel 1. Let us generate the report. We see the whole data that we are entered in the calculations. Now we can print this data here. Actually, we have size, absolute distance to the tube. You see the pipe segments is named by the segment, pipe 1, pipe 2. And EC1 means that end cap 1. Size of the, this is the diameter of the holes. This is absolute distance, relative distance. And if we used capillary, then we had some data here, but we do not use it. Okay. We may print it, and you see that we see the pipe layout schematic, and if we make the bigger page, then we will see that this is segment pipe 2 and this one is pipe 1, and so on. If we proceed, okay, it's too big, let it be. Then we see end cap, hole 3, hole 2, hole 1. This is only for the first channel. And we see the location of the hole. It's 40 centimeters for the first pipe, then it goes 3.5 meters and 8.5 meters. So all settings are on the drawing. You see, we see the drawing colored, but we also can do this, the trick that we just control click to the pipe on the pipes, and then we make a report again. And you see now the document is created and the same data is, but you see that we have gray tubes and end cap. If I would select the detector, it would also be gray. Okay. Imagine that this detector is set in the same room where this sensitivity is important. Now let us continue to the second channel. And for example, we create some class C classification. Pipe material we will use ABS. As far as I understood, that these materials only differ the pipe diameter and inner diameter. Maybe some other info, but I don't know about that. Sample hole size, let we choose 3.5. It's okay for us. And for example, we will choose a room that is, for example, a long room, 45, for example. Let it be some corridor. And the detector locate is outside the room. And you see, it tells me that exit back into the room when possible to avoid issues arising from the pressure difference. We will do that after. And let we set that the pipe goes from top to the bottom. Again, we use pipe location below ceiling. Location distance below ceiling is 10. Let we set it 5, for example. And you see, and already some limitation. The distance cannot be lower than 10. Okay, let it be 12. Okay, we will finish with this setup, and you see detector is located up here. Let me switch the view. Yeah, detector is located up here, and then the pipe goes here and here, and you see that it's already set me some holes and the end cap. Let me see what did it set for me. Okay, you see isometric view. I can choose some properties. I switch to front view, for example. Now I have the holes, I have all the parameters, I have end cap with the sensing hole. I can add another hole, for example, here. Okay, let me see it. Okay, and distance to the first hole and between the holes let it be 7, for example, update holes. And now all relative distances are updated and absolute distances as well. Okay, and let we have some capillaries. For example, this one will have capillary. Capillary length is 1 meter and diameter is 8 millimeters. Let it be, for example, 0.4. Okay, and you see on the drawing we have the capillary added. And this is bad view. Let me see this way. This way is better. Okay. Now again I go to the calculations. Also I have auto balance. You see the hole diameters are the same, but if I press auto balance, then it will change to the best fit. But actually I will use the same diameter for all holes, because for example if installer has a drill that is 3.5, he will use it is convenient to use on hole piping the same hole diameter. Flow control is 32. Okay, let me have it a little more, for example. Then the fan speed is not so low. I don't remember which fan speed I set on the channel 1. Let me check. Okay, let it be 5. 5 is okay. Yes. And let me check what I did on the channel 1. I had the speed was in the calculations and the speed was fan speed 10. Okay, let me try 1. Yes, 1 should be lower speed. And on the second channel I will use calculations. I will set 5. Okay, I just want to know if I can set different fan speed on different channels. I will see it when I will physically test the device. Now I only calculate. I don't know is it correct or not. But let it be this way. Also I want to show you that I can show some labels here. I will show all labels, for example. And you see I have the pipe, the bend, the holes, and the end cap. End cap is a hole. And again I can create a pipe layout that will generate the pipe layout. All necessary data also is in here, as on the previous pipe on the previous channel. You see capillary length is added here. Okay, I also now want the add to exhaust pipe. For that I will double click on the. Okay, I cannot click while I am in the isometric view. Okay, let me click and I will add exhaust pipe, for example 2 meters and the diameter of the pipe. And also we can add filter, but you see that filter will impact on the transport time. But okay, let it be this way. Let me see the calculations again. Okay, so when I added filter, then it's not already acceptable. So I will choose fan speed a little bit higher. Okay, apply settings. And now again, reports. It created me a report. Now I can print this report. As I know I have no printer installed, I will print it to the PDF file. Let me set it, for example, to pipeIQ and name it calculation 1. Save. We will see after how the document looks like, and also we can export to DVG. Let me set it calculation 1. Save. Okay, now we completed the calculation. Let me see the report for the channel 2. The same can be done for the channel 1, as you understand. And let me see what DVG file it created. Okay, now it's ready. Let me see. Let me try to measure it. Measure. Okay. It doesn't give it me. Never mind. AutoCAD users will find out how to measure that. That's all for now.